So we can have nested loops, just like we can have nested conditionals. Last week, we looked at having if statements that were inside of other if statements. We can have loops that are inside of other loops. And in Python, the way you're going to show that is with indentation. So here, this first for loop heading right here, this line on top in green says for I in range 1 through 3. Some people call that the outer loop. Some people call that the parent loop. That is going to be the first line that the computer encounters. Remember that your code is going to be read top to bottom, left to right. So it's going to come to this line first. And we mentioned last week that the way a for loop works is you know that, or you use that when you know the number of times you want the loop to run, when you know the number of iterations that it should make. So this is saying for I in range 1 through 3. So we would start at 1, we would go to the 3, but not include it. So this would run for I equals 1 and 2, but it wouldn't include the 3. So it would stop there. So you would just have 1, 2. So this outer loop is going to run twice. However, every time that outer loop goes through an iteration, the inner loop is going to run a full cycle. So here we have another for loop. So this says, when I equals 1, go ahead and do everything inside the loop. Well, what happens inside this loop is another loop. So here we're going to have for J in range 1 through 4. Well, that's going to be the numbers 1, 2, 3. So my inner loop is going to run 3 times, okay? And then what do I want to happen? This print statement right here has been indented twice, right? Once to show that it's part of the outer loop, again, a second time to show that it's actually part of the inner loop. So this has 2 indentions for this print statement. And it says print I times J. Okay, so it's a lot easier for me to explain what's happening here when I have a whiteboard and I can kind of draw stuff out a little bit, but hopefully it'll make sense if I just verbally go through it. So the very first time we come through the code, I is going to equal 1. So right now I equals 1 for this whole entire cycle of J that we're about to do. So I is 1, we come into the inner loop, J is going to start at 1. Okay, so here's I over here in this hand. This is going to be J. 1 times 1, 1. Now, that is all that we asked this inner loop to do. So when it finishes running all of its commands, it comes back up to the loop and it increments. Now we have gone up to the next number. Now J is equal to 2. But I still equals 1 because we haven't finished everything that the parent loop asked us to do yet, right? This outer loop is going to ask me to go through this entire thing. So I is going to remain 1 for all of the iterations of J. So now J is going to equal 2. 1 times 2, 2. I increment J. 1 times 3, 3, right? Remember that we don't include this second number whenever we have the command range. This tells me where to start and this tells me where to stop, but I don't include it. So J is going to run through the numbers 1, 2, 3. Okay, and you can see that here 1, 2, 3 times 1 gives me 1, 2, 3. Whenever we finish this entire inner loop, we'll come back up to the outer loop. Now we would increment I would equal 2. When we come back inside here, we run through everything of J again, 1, 2, 3. The difference is The second time we go through this, I would be 2. So we would have 2 times 1, 2 times 2, 2 times 3. That's where we get this second set of output is 2, 4, 6. You don't need nested loops for program 3. And you don't need nested loops for quiz 3. So I'm not really going to show many examples in my programming today, just kind of covering what a nested loop is and kind of the timing of how it works. So this is going to be the same thing. The only difference is that they kept the output for each inner loop on one single line. So you can kind of see when I equals 1, what's it going to do? Print out 1, 2, 3, because J would equal 1, 2, 3. And then it skips down to the next line. What are we going to do when I equals 2? We would print out 2, 4, 6. 2 times 1, 2 times 2, 2 times 3. Our final slide says the inner loop is going to go through every iteration each time the outer loop goes through 1. And the total number of iterations would be the number of times the inner loop runs multiplied by the number of times the outer loop runs. So those are all of our slides on loops. I already have Replit opened up here, and we're just going to program some examples. And just kind of not just about nested loops, but even just going back to the video from last week, from last Thursday, program some examples of the while loop that we talked about on Thursday, and just a simple for range loop. Okay, so let's start with a while loop. In the video from last week, we had just a very basic, had an X and a while loop that just runs like 2 or 3 times, and the X just gets incremented each time. And in that example, the X is our loop control variable. It controls the number of iterations, the number of times that our loop runs. So let's take a look at that. Let's start at X equals 1. Really simple. And I'm going to use the reserved word while. So while is a reserved word. It has special meaning. It tells the computer as long as this conditional that comes after it is true, then I want you to continuously run the lines of code that come after it, right? So I could say, as long as X is less than 3, then what do I want it to do? I'm going to just print out the value that's inside of X. So if I do this right now and I run it, can you sort of like predict what the output would be? Before I hit run, can you think in your head what it's going to do? So let's kind of walk through it a little bit here. This would be a logical error. You might have realized it, or you might have forgotten because it's been a few days since we looked at it. But this would say, what is the value that's inside of X? 1. Evaluate to see if this conditional is true. Is 1 less than 3? Yes, it is. Run the body of the loop. I print out 1 because the value that's inside of X right now is 1. So I would print out the 1. And then it would come back up here and it would check the conditional again. The value that's inside of X is still 1. So 1 is still less than 3. That is always going to be true. Print out the value that's inside of X. It still equals 1. So it would print out a 1 again. So this is an example of an infinite loop. And you can see it went very quickly. I can hit stop. It was still running because it's just running continuously. You can't really even tell the difference because it prints out so fast. If I scroll up, you can see it's just a wall of ones because it just printed out over and over and over again. If we want to avoid an infinite loop, I need to approach the conditional eventually becoming false, right? So if I'm starting at 1 and I want to work my way up to 3, what I would need to do is increment my loop control variable. I would want to add numbers to it so that I would be approaching 3. I would be approaching becoming greater than 3 or equal to 3, because in those cases, my conditional would become false, right? So now I don't have a forever loop anymore. Now we only printed out 2 things and then we end it, right? So we started at 1. 1 is less than 3. So we printed out the 1. And then we added 1 into x. So now x equals 2. So I come up here, 2 is less than 3. That is true. Run the body of the loop. So I print out the 2 and then I add 1 to my value of x. 2 plus 1 is 3. You come up and you check the conditional again. 3 is not less than 3. So we fall out of the body of our loop. And you would continue on with the next piece of your code. Now, I don't have anything farther on in my code, but if I wanted to add something, that I wanted to run outside of the loop, like something that I would want to print after the loop was done. So maybe we could say something like outside of the loop. So this doesn't get repeated, right? This, even though my loop ran twice, this line only printed out once because it's not part of the loop. I could make it part of the loop by indenting it over, but here you can see that this is kind of, vertically aligned over here on the far left. It has not been tabbed over, so it's not part of my loop. It is only going to run after everything that is inside the loop finishes. If I made a simple change here, if I made that less than or equal to 3, now my loop is going to run 3 times instead of twice. 1 is less than or equal to 3, 2 is, and 3 is as well, because 3 is equal to 3. So be mindful, when you're trying to think of how many iterations it would run, be mindful of whether or not you are saying just less than by itself, or if you are saying less than or equal to, right? Because this one would potentially run an extra iteration. So watch out for that. Okay, another thing that we could do. So here I started low and I incremented because my loop control variable was that, it was higher. I was going up to 3. We could work backwards as well. So for example, if I started at 10 and I said, I want you to run until you hit 1. What the logic that I would need to change for that, there's 2 things that I would like to switch so that I can continue, my loop will continue to run, but it'll work correctly if I start high and I come down low. So one thing that I'm going to change, starting, at 10 instead of starting down low, but the 2 parts of my loop I want to switch, I need to switch my relational operator. I want to say as long as 10 is greater than the value 1, right? If I am bigger than my value, then we can go ahead and run the body of the loop. The second thing that I have to change is the way I am updating my loop control variable. If I start at 10 and I'm trying to get to 1, and my update says every time you run the body of the code, add 1, right? If I'm starting at 10 and I say 11, 12, 13, 14, I'm always going to be greater than 1 because I'm continuing to get bigger. If your logic is that you are going to start at 10 and you want to come down until you hit 1, you should be subtracting. Your number needs to be getting smaller. So in this case, we should run through the numbers 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We do include the 1 because we had greater than or equal to. And I only print outside of the loop 1 single time because it was not indented and that was not part of my loop, right? So you can see that's only in here once, even though my loop ran 10 iterations. Okay. So that's kind of everything for while loops. You use the reserved word while, you put your conditional right after it, followed by a colon. You indent everything that you want to be part of your loop. You can start small and then go up, or you can start big and go down. Just make sure that you have some sort of update in there where you are approaching the conditional eventually becoming false. Otherwise, you can accidentally wind up with an infinite loop. Okay, so I think that's kind of everything I want to cover for while loops. Let's go ahead and talk about, let's do an example of the accumulator and the counter, which were both in the slides that we talked about last week. So I'm just going to say count equals 0, and I'm going to say sum equals 0. And then let's just do the numbers 1 through 10. Why not? So I'm going to say, I'm going to use, I'm going to use count as my loop control variable. That's fine. So we're going to say, go through the numbers. No, I'm not. I'm going to use X as a loop control variable. Just kidding. So we'll start X equals 1, and let's go through the numbers 1 through 10. Okay. And here are all of the things that I want to happen. So we're going to add 1 to our count. We are going to add each new number to our sum. And then we are going to update our loop control variable so that we will eventually fall out of our loop. So we're going to do 3 things inside of this loop. Okay. Number 1, increment your counter. So I have a variable called count. It starts at 0. And each time that I go through an iteration of my loop, I'm just going to add 1 to my count. 1, 2, 3, 4. So I have the variable count. And each time I just want to add 1. That's it. I also have the variable sum. However, I don't want to add 1 to sum, right? Sum should be a running total. So if my first number, if my X goes through the numbers 1, 2, 3, 4, 5, 6, my first number, I add 1, right? Because X is 1, that's fine. But then X is going to be 2. And then it's going to be 3, and then it's going to be 4, right? I want to add the numbers 2, 3, 4. I don't want to add a 1 every time. So we kind of have to think, what can I add to sum that's going to add our new value each time? It's going to be another variable. We can add the value of one variable into another variable. So if X is going to be our loop control variable and it's going to run through the numbers 1 through 10, I want to take each one of those numbers and add it to my running total, my accumulator. Okay. And then of course I need to update so that I will eventually break out of my loop. So if I'm starting at 1, I'm going up to 10. I want to increment up by 1 each time. Now, how will I know that I actually did this correctly? I would like to print out the results. I would like to kind of see the final results outside of my loop after I have ran through everything. So let's say count the number of iterations. How many times did this run? That is going to be however many numbers we count. And then we are also going to say add, let's say running total of numbers. And where is that value going to be stored? We added up each value inside of sum. Okay. So how many times did it run? 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We include the 10 because of the equal sign, less than or equal to, right? 10 iterations. Sum is the numbers 1 plus 2 plus 3 plus 4. So this was not the number 10. This was a total, not a count. So there are examples of counting and an example of an accumulator, and then doing multiple things inside of the while loop and printing out those final results after the loop. The final thing that I'll show you, and then we will wrap this video up, is going to be the for loop. Let's do an example of the for loop. We saw 3 different ways that you could write it in the slides. You could use range with 1 single number. You could use range with 2 numbers, and you could use range with 3 numbers. So let's take a look at that. Let's say for I in range, let's do just 1 number, 5. And what we're going to do is just print out I. So, oh, right, I forgot my, I forgot my parentheses. So if you only give it 1 number, that is going to go from 0 up to this number minus 1, okay? So this is going to print out 0, 1, 2, 3, 4. It does not include the 5. It runs 5 times. So we're telling the computer that it's going to make 5 iterations, but because it starts at 0, it doesn't include the 5, right? 0 through 4 gives me 5 iterations total. And we can print this out and see the results 0, 1, 2, 3, 4. Another example would be if we gave the computer 2 numbers. If we give the computer 2 numbers, we are saying start here, stop here. Again, it is non-inclusive for the final value. So 10 minus 5 is 5. This is going to run 5 iterations. So that would be the numbers 5, 6, 7, 8, 9. Does not include the second number. And we can, okay, so you can see that if we change it to be the 2 numbers, you know, the start and the stop, then it shows starting at 5, running 2, but not including the 10. So it prints out the 5, 6, 7, 8, 9. The final example is if we used a for loop with 3 numbers. So in this case, we are telling it a start, a stop, and a step. And the step could also be called, you know, the update. It is every time you go back through the loop again, how much of a jump, how much of an increase are you making from one number to the next? So in this case, if I start at 5 and I go up to but not including 10, and I'm going to skip by 2s, right? So start at 5, skip. I'm going to add 2, give me the 7, skip, give me the 9. At that case, at that point, I would be done, right? Because we don't include the 10. So this would print out 5, 7, 9. So for example, if I wanted to print out maybe like all of the numbers, 1 through 100, but I'm going to skip by 10s. So if I start at 1 and I add 10, my next number would be 11. Okay, and then you could give me like all of the 10th ones, and I don't include the 100, so I stop there at 91. It'd be an example of that. Okay, and then we could also, we could show it going negative if I wanted to go backwards. So I could say, for example, start at 100 and then go all the way, down to 1, but not including it. But instead of adding 10 every time, I want you to subtract 10. That could be my update. So I could go from 100 down to 90, 80, 70, 60, 50, and so on. And that is everything for loops. So we have covered while loops and for loops. We've gone through making infinite loops. We've done examples of accumulators and counters. We've seen some different steps, and we have shown the for loops with all 3 possible input parameters.